How do you solve a problem as massive as global water pollution? Well, it turns out the answer lies in understanding something incredibly, unbelievably small, the tiny, invisible particles that make up, well, everything. So let's dive into how pure science can actually lead to pure water.
You know, this quote really hits home. Clean water is something a lot of us just expect to be there when we turn on the tap. But for millions of people, it's a daily crisis. The need for new ways to clean our water isn't just some interesting science project, it's a genuine global necessity.
And here's the scary part. The threat is often completely invisible. We're not just talking about water that looks dirty. We're talking about things like dioxins, mercury, and lead. These are things that can be in water that looks crystal clear, but they're incredibly dangerous and can cause really serious, long-term health issues.
But this is where the science gets really cool. People like research chemist Lee Wilson are tackling this invisible threat at its own level, the microscopic one. He's creating these amazing new materials that are basically the world's most advanced sieves. Think of it like a filter with holes so tiny they can literally catch those nasty pollutant particles, but let the pure water molecules sail right on through.
And that's the million-dollar question, right? How in the world do you build something that precise? To create a solution on a scale that small, you've got to first understand the fundamental rules of how those tiny particles work. You have to go right back to the very basics of what our world is made of.
So here's our game plan for this explainer. We'll start with water itself as a world of particles. Then we'll zoom way in on the building blocks of all matter. From there, we'll switch gears and look at how scientists actually work with this stuff by investigating it safely, which means knowing the rules of the lab, and finally, learning how to decode those all-important hazard symbols. All right, to get a handle on the world of particles floating in our water, we first have to understand the science behind all particles. So let's jump into the absolute fundamentals. The building blocks of matter. This is really the science behind the solution.
At the very heart of it all is something called atomic theory. And it's a really simple but incredibly powerful idea. Everything you can touch, see, or feel is made of tiny, tiny particles called atoms. The way these little atoms are put together and the way they act determines literally everything about a substance.
And you can see this idea in action everywhere, even in art. Think about it. The original Mona Lisa exists because artists understood the properties of oil paints, their colors, how they dried, their texture. Now fast forward to today, and an artist can create the same image using neon gas because we understand its unique atomic property of glowing when you pass electricity through it. It's the same subject, just totally different technologies. All thanks to understanding atoms.
And get this image shows you just how unbelievably small we are talking. This isn't a computer graphic. You are looking at actual individual iron atoms that scientists have arranged on a copper surface. That whole ring is only a billionth of a meter across. I mean, my brain can't even really picture that. Being able to see and move things at this scale is how we get breakthroughs like Lee Wilson's filters.
Okay, so we've got the theory. We know everything is made of atoms. But to build new things, scientists have to experiment, and sometimes that involves some pretty hazardous stuff. So that brings us from theory to practice, where the number one most important rule is always safety.
Yep, to really understand matter, you've got to get in there and do experiments. But this picture? This is a recipe for disaster. So, here's a little challenge for you. Take a good look at this lab. How many unsafe things can you spot going on here?
So how'd you do? Let's go through a few of the big ones. Eating or drinking in the lab? That's a classic way to accidentally poison yourself. Long hair that isn't tied back near a flame? A huge fire risk. No safety eyewear? You're just one splash away from serious eye damage. And a messy workspace is just asking for spills and broken glass. For every one of these, there's a simple, much safer way to work.
Okay, so beyond avoiding total chaos, there are some really strict rules that make science possible. Let's look at the core guidelines that shape every single experiment, whether it's in your school or in a high-tech research facility. These are pretty much the golden rules. First, always work with a supervisor. Second, you have to read the entire procedure before you touch anything. Third, never ever use chipped or cracked glassware. A tiny flaw can become a big problem. And finally, you always know where the emergency stuff is, and you report every single accident, no matter how small.
Now, some rules are incredibly specific, and for a very critical reason. Here's a famous one. You always add the acid to the water, slowly, never the other way around. Why? Because if you dump water into concentrated acid, the reaction can create so much heat, so fast that it instantly boils and can splash dangerous acid all over the place. Following that one simple rule prevents a whole lot of trouble.
You know, safety is also about learning the right moves. For instance, you never just stick your nose over a chemical and take a big sniff. Instead, there's a technique called wafting. You hold the container a safe distance away and gently wave or waft the vapors toward your nose. It's a smart, controlled way to check for an odor without getting a dangerous lungful.
All right, beyond the rules and techniques, there's a whole visual language designed to keep people safe. Let's wrap up by decoding the symbols that give you critical warnings in just a single glance.
You've probably seen a version of these symbols on products you have at home. And here's a neat trick. It's all in the border. A triangle shape like a yield sign means the container is the hazard, like it might explode if you puncture it. But an octagon, like a stop sign, means the danger is the actual stuff inside the container. It might be poisonous or corrosive.
Now, in a professional lab or a school, things get a bit more standardized. We use a system called WHMIS, which stands for the Workplace Hazardous Materials Information System. It's basically a universal set of warnings, so everyone is on the same page.
So let's do a quick lightning round of the most common ones. A flame, that means it's flammable. The skull and crossbones, that's for poison that can cause immediate harm. The test tubes bubbling on a hand, that's corrosive material. An exploding bomb means it's, well, explosive. And that T with a dot is for things with other, maybe slower toxic effects. Knowing these is like learning the safety alphabet.
So we've gone all the way from the theory of the atom to the nitty-gritty rules of the lab. Let's bring it all back together. Why is all this so important?
It's because you absolutely can't have one without the other. It's the combination, having the amazing knowledge to understand the invisible world of atoms and the discipline to explore it safely. That's what lets people like Lee Wilson solve our biggest problems. Knowledge plus safety. That's the real formula for progress.
When you think about it, safety isn't something that holds you back. It's the exact opposite. It's the launch pad that allows us to explore, to create, and to solve the biggest challenges we've got. It's always the first step. So the only real question left is, what will you discover?